Another thing we need to talk about is something called boundaries. And boundaries are important when you're working with a continuous variable. Okay? So let's look at this idea of boundaries. Okay? And this is used with continuous variables. Okay, the idea here is, and let me zoom out here. So the idea of the boundaries is, if I said I weighed 198 pounds, okay, and you're like, oh, I weigh 198 pounds too, would we weigh the exact same amount? And the answer is probably not, okay? I got a bunch of atoms in my body, and you have atoms in your body, and if we totaled them all up, they're probably not going to be exactly the same, okay? But we both say we're 198 pounds because that's the number we're closest to, okay? So when we have a continuous variable, what we have to do, you could be anywhere on that scale, and what you have to do is you have to decide which number am I closest to, and then you're going to say that in this case I'm 198 pounds. So here's the idea. Okay, so here's my scale, and you could be any weight in here. Okay, but I'm 198 pounds, and let's say you're 198 pounds. What it means here is that we're probably somewhere in this range. Okay, these are the boundaries for 198, and this one would be 197.5, and this would be 198.5. And these two numbers are the boundaries for 198. If I'm in that range, okay, then I'm going to say I'm 198 pounds. To the nearest pound, I'm 198 pounds. Okay, so these boundaries are just halfway between, in this case, 197 and 198, and between 198 and 199. Okay, so the boundaries for 198 would be 197.5 to 198.5. Okay, so the boundaries are a range for a particular number. Each whole number has a boundary. Okay, and to be more specific, what I would say here is the boundaries for 198 is 197.5 all the way up to, but not including, 198.5. And then the boundaries for 199 would be 198.5 all the way up to, but not including, 199.5. So these would be the boundaries for 199. So the idea is the boundary here for 198 would include the 197.5, but it would not include the upper boundary. So it'd be 197.5 all the way up to, but not including, 198.5. If I said that I was like 198.2 pounds, what that would mean here is that I'm measuring to the nearest tenth of a pound. I'm just being more accurate in my measurements. Okay, so this would be like, let's say 198.0, 198.1, 198.2, 198.3. 0.4. So this would be my new scale, and I'm measuring to the nearest tenth of a pound. So in that case, the boundaries here would be halfway between these two. So the lower boundary would be halfway between 198.1 and 198.2, and that would be 198.15. The upper boundary would be halfway between 198.2 and 198.3, which would be 198.25. Okay. So the boundaries for 198.2 would be 198.15 all the way up to, but not including, 198.25. So now there's a simple rule. You don't have to draw out the scale each time. If I'm given a number, so let's say like 2.315 grams, and I want to get the boundary here for this. Well, this is to 3 decimal places. So they're measuring to the nearest thousandth of a gram. They're being very accurate here. Okay, so if I wanted the boundaries here, the way I could do it here would be, a simple way is to take the very last digit in the decimal number and lower it to 4 in this case, and then add a 5. And then now for the upper boundary, I'm going to rewrite the number and then add a 5. So the lower boundary is the same number with the last digit lowered, and then I add a 5. And then the upper boundary is the exact same number, and then you add a 5. Okay, so, and this will work for any numbers. Let me give you some examples here. So let's say 1.6 ounces. Well, this would be the last decimal place is a 6, so I lower that, and then I add a 5, and then I just write 1.6 and add a 5. Okay, so if I had 0.3215 seconds, okay, so then I would rewrite this whole number, but I would lower this 5 down, so 0.3214, add a 5, and then I would rewrite the same number and then add a 5. And these would be the boundaries. Okay, now most of them we have will be whole numbers. So when you use boundaries, they're probably always going to be whole numbers. And in this case, it's like adding and subtracting 0.5. If I subtract 0.5, it would be 177.5. And then adding 0.5 would be 178.5. Okay, but it's the same idea. I lowered this to a 7, and then I added, in this case, a 0.5, and then I rewrote the number and then added a 0.5. Okay, and really the rule here is I added, subtracted 0.5. Well, what I did for this one is I added or subtracted 0.05. Okay, because it has 1 decimal place. So you're always going to add and subtract a 0.0, however many zeros, and then a 5. So it's always going to, if there's 1 decimal place, then it's going to be 1 0 and then a 5. In this case, there's 4 decimal places, so I'm adding, subtracting 0.00005. So what I'm doing is there's 4 decimal places, there's 4 zeros, and then a 5. And then if I took this number and subtracted that, I would get this one. Added that, I would get this one. That's really what's happening. But really the rule that I give you, lowering this and then adding a 5, and then adding a 5 works. Okay, that's an easier way of doing it. So here's a daily activity for you. What you're going to do is you're just going to find the boundaries for these numbers. Okay, so go ahead and press pause and work on that. Okay, so you're back. Let's look at these. So the boundaries, I'll write the numbers here, and then we'll do the boundaries. So 1 is 152, 2 is 69, and the units aren't necessarily important. But the point of these units is it's always when we're measuring something that these boundaries are really important. Okay, when we make measurements, because measurements are continuous variables. Okay, and these are really important when you're using continuous variables. So 152, this would just be 151.5 all the way up to, but not including 152.5. So this would just be 68.5 all the way up to, but not including 69.5. This one would be 0.465 all the way up to, but not including 0.475. Okay, I just lowered this to 6 and added 5 for the lower boundary, and then I just kept it 7 and added 5 for the upper boundary. Same here, this would be 3.2, that would be 45, and then 3.255. And then the last one would be, now this one's a little tricky because that's a 0, and if you lower it, it's going to bring it down to 9, but then you have to carry it over. So this, if you think of that as 30 and lowering 30 by 1, you would get 29. That's one way of thinking about it. So this would be 7.295. So I lowered, instead of lowering just this decimal place, I'm lowering 30 to 29, adding a 5. And then I keep it at 30 and add a 5. Okay? And these would be the boundaries for these numbers.